Welcome to our chemistry channel. In this lesson, we are looking at pressure law. Don't forget that we started a series of teaching on gas laws, and we have looked at Boyle's law, Charles law. So you can check those out on this our chemistry channel. But today we are looking at pressure law. Pressure law. What does pressure law state? Pressure law states that the pressure of a given mass of gas is directly proportional to its absolute temperature, provided volume remains constant. Pressure law states that the pressure of a given mass of gas is directly proportional to its absolute temperature, absolute or Kelvin temperature, provided volume remains constant. Mathematically, pressure law can be written as P very directly with T. Then if I remove this proportionality symbol, I will introduce a constant T, constant K rather, and you have P equal to KT. Then at different pressure and temperature, it means that K can be equal to P over T. Then from there you can have P1 over T1 is equal to P2 over T2 is equal to K. So this is pressure equation, where P1 is your initial pressure, T1 is your initial temperature, P2 is your final pressure, while T2 is your final temperature. P1 is your initial pressure, P2 is initial temperature, T1 rather is initial temperature, P2 is final pressure, while T2 is final temperature. P1 initial pressure, T1 initial temperature, P2 final pressure, T2 final temperature. Now, pressure law, the graph of pressure law can be drawn like this. So you are drawing pressure against temperature. If you are drawing pressure against temperature in degrees Celsius, then the graph looks like this. This is minus 273 degree. This is how the graph looks like. Pressure against temperature in degrees Celsius. But if you are plotting the graph of pressure against temperature in Kelvin, that is the absolute temperature, then the graph will look something like this. You have pressure against temperature in Kelvin, that is absolute temperature. In that case, the line will start from the origin. So these are the two ways you can draw graph of pressure law. Either pressure against temperature in degrees Celsius, which will look like this. This minus 270, we call it absolute zero temperature. Or you are plotting pressure against temperature in Kelvin. Then you have a straight line graph that passes through the origin. So this is the graph of pressure law. Now, how does kinetic theory explain pressure law? How does kinetic theory explain pressure law? Now, pressure can be defined as the number of molecular collision between the gas molecules and the wall of the container. The number of molecular collision, that means how frequent the molecules of gases in the container collide with each other and collide with the wall of the container. That's pressure, the number of molecular collision or the frequency of collision between the gas molecules and the wall of the container. Now, peradventure, you have a container like this, then contain gas molecule like this. Now, these molecules, they occupy this volume. Now, by increasing the temperature, if you increase the temperature, let's assume the temperature is at 0 degrees Celsius originally. Then the temperature is now increased to 60 degrees Celsius. Now, if you increase the temperature of these gas molecules, what will happen is that the gas molecules will gain more temperature, they will gain more kinetic energy also. That is, they will be able to break free from intermolecular forces that are holding them together. When you increase the temperature of these gas molecules, they gain more kinetic energy. That kinetic energy is to enable them to be more energetic, so that they can be able to break away from intermolecular forces holding them together with each other.